Okay, so what I want to show you next is operating characteristic curves, also commonly referred to as OC curves. Okay, so I'm going to draw for you what these curves generally look like. So this is going to be the end product, and the x-axis is going to be percent non-conforming. And we're going to commonly write it down as 100 times the percent non-conforming in that lot. And the y-axis is percent of lots accepted. And this will commonly be written as 100 times P, capital P, superscript A. So how do we interpret this graph? Well, let's just pick a point and talk about it. Let's say this point, this black dot, represents, 2% non-conforming. Let's say that's 2. In that case, well, first of all, I need to tell you that this scale goes up to 100. So if we had 2% non-conforming, let's say this lines up to be 95% lots accepted. So we have 2% non-conforming. That means about 95% of the lots will be accepted. Okay, next I want to teach you the 5 steps to construct one of these OC, operating characteristic curves. Okay, step number 1 is to assume the percent non-conforming. Those will make sense as I show you a table in the next slide. But basically for now, just think about it. We're assuming each of these values. So we're just going to arbitrarily pick them and then back calculate what each of these corresponding percent lots accepted values are. Okay, step number 2 is to calculate the NP value. So for each of these P values, we're just going to multiply times how many we have in our sample size. Okay, the third step is to obtain the PA values. Okay, step number 4 is my favorite part because this is when we get to plot this data. And then step 5 is we're going to repeat steps 1 through 3 until we get the rest of these values. So we're going to assume this one, we're going to multiply it times n, then we're going to get each of the values for the y-axis, then we're going to plot those as we do it, so we'll plot them one by one, and then we'll repeat them all together.
Okay, so let's go with an example here. This is a table taken from the course textbook showing the process of determining the probabilities of acceptance for the various p-values, proportion non-conforming. So what we're going to do is just hypothetically assume that we have 0 proportion non-conforming and multiply that times n, which is going to be 0, and use that number to look up the corresponding probability of acceptance, which in this case is 1.0. And then we'll do that for 0.005, multiply that times n, in this case n is 50, so we get an NP value of 0.25. Then we're going to use this NP value to calculate the corresponding probability of acceptance value of 0.997. And we're just going to continue to do this until that probability of acceptance goes from 1 all the way down to something approaching the asymptote near 0. And with that, we have everything we need to plot the operating characteristic curve because remember, P, that first row, proportion non-conforming, is the x-axis, and PA, probability of acceptance, the third column, is the y-axis.